Greetings, Math 10 students. In this video, we're going to be taking a look at section 7.3 from the textbook, Adding and Subtracting Polynomials. If you haven't already taken a look at section 7.2 or learned the gist of what polynomials are, I'd recommend checking out the video on 7.2 and reading through that bit of the textbook. I'm going to be using a lot of vocabulary having to do with polynomials, talking about things like terms and coefficients and exponents and bases, and it's good to have a feel for what those things are. That being said, taking a look at this, if you watch this video, you'll probably feel like you've seen a lot of this before, and that's because you have. Adding and subtracting polynomials is basically something that we did in Chapter 5 already. We're just calling it something slightly different. There are a couple little details that you're going to want to pay attention to, but otherwise, this is basically just going to be combining like terms. So let's go ahead and have a look. So first of all, the directions will often say something abstruse like perform the indicated operation. Great, what does that mean? Sometimes they'll say find the sum or simplify. Again, very vague. Every once in a while they're nice and they will say add. So how do you know that it's an addition? There'll be a plus sign between the polynomials. And like I said, what you're going to do is just combine like terms. Some little pointers to keep in mind. I'm going to encourage you to keep track of your work by starting with the largest exponent, combining those terms first and working your way down. Like terms have to have the same variable and exponent, so looking for the exponents that are the largest, combining those first, and then the next largest and combining those is a good way to keep track of your work. I'll also underline or circle terms to check them off as I go, another good way to keep track of things. Also, you're going to be adding and subtracting the coefficients using the sign rules for addition, so just be very careful with your negative signs. Most of the mistakes with this happen because of negative signs, and there are a lot of terms to combine sometimes, so just be careful with those negative signs. And don't forget to bring down your variables and exponents. That's the other place that I'll often see mistakes. So enough talk, let's look at an example. Whew, that looks terrible, right? But don't panic, this is just combining like terms. How do I know that it's combining like terms or an addition? Because between the parentheses, so in this first set of parentheses here I have one big polynomial, and in the second set I have a big polynomial, but between them there's a plus sign. That's how I know it's addition. And if it's addition, you can ignore those parentheses. They're meaningless. They don't actually do anything. So just ignore them and combine your like terms. So we're going to start with the largest exponent. Not the largest coefficient, the largest exponent. And the biggest exponent I see is a 5. I see two terms with an x to the 5th power. There's this 3x to the 5th power and a 2x to the 5th power. So I'm just going to go ahead and combine like terms. 3 plus 2, I'm just adding the coefficients. They're both positive. 3 plus 2 is 5. And I'm going to bring down the variable and exponent. The base and the exponent come down. So 3x to the 5th plus 2x to the 5th is 5x to the 5th. There's my first set of like terms. Take a deep breath and move on to the next one. Don't look at this as one big problem. Just look at it as a bunch of little problems. So I'm done with my x to the 5ths. I move on to the exponent of 4. And indeed I see a couple of them. There's a negative 9 x to the 4th and a negative x to the 4th. Well, wait a second. That doesn't have a coefficient. But you guys know this trick. If there's no coefficient, you just put a 1, right? So it's a negative 9 and negative 1. I'm going to combine those using those sign rules for addition, which say if you have the same sign, you're going to add and keep the sign. So I owe you $9. I owe you 1 more, so I owe you 10. Negative 9 minus 1 is a negative 10, and bring down your x to the 4th. Never change your base or exponent when you're combining like terms like this. When you're adding and subtracting, you just keep those the same. All right, after 4 comes 3, so let's see if we have exponents of 3, and indeed we do. I have a plus 6x to the 3rd and a minus 5x to the 3rd. And you'll notice I'm kind of circling these or boxing them in. It's another good way to keep track of these and make sure that you get all of your terms. All right, so I just combine those coefficients. A 6 positive and a 5 negative, different signs, so I subtract. 6 minus 5 is 1, and then bring down the x to the 3rd. If you're really familiar with this, you might be cringing right now. Don't panic. I'm going to go back and address that. So first of all, one thing that I need to address is that I have to have signs between my terms. So oftentimes if something's positive, you don't write the plus sign, but this is a situation where you would. 6 is bigger than 5, so my final answer is positive, and I do need to write the plus sign here because I need to have signs between all my terms. I don't have to have a sign with the very first term, but there have to be plus or minus signs between all the other terms. So I will write that plus sign in there. The other thing that you might be cringing about is that 1. We don't need to write that 1. That 1 is a coefficient of 1, so I'm going to get rid of that. Whenever your coefficient is 1, you just don't write it in your final answer. I'm going to erase that 1 there. We don't need it. That's just x to the third. All right, next up is going to be the x to the second powers. So I see a minus 3x to the second power, and uh-oh, nope, that's not a typo. There's no other x to the second power. So what happens? You throw up your arms in disgust, walk away, and say, I can't do this. No, you just bring it down. There's nothing for it to combine with, so you just bring it down. That's going to be negative 3x to the second power. Doesn't change. There's no one for him to match up with. All right, what happens next is my x to the first power, or just plain old x, and I have a negative 8x. Maybe I'll triangle that in, I don't know, and a positive 8x. Okay, so different signs I subtract. 8 minus 8 is 0. Well, I don't want to just bring down the x because that would mean there's a 1 in front, kind of like what happened here, right? So what am I going to do? Those are just going to cancel out. Those terms cancel out completely. I don't even write the x. And then last but not least, I do have this straggler of negative 2. That constant term is just going to come down at the end and just write the negative 2. And here's my final answer. 5x to the fifth minus 10x to the fourth plus x to the third minus 3x to the second minus 2. That's it. And you will type it into Hawks exactly like that. They want the big old formula just like that. All right, let's take a look at a subtraction. Again, the directions are going to be very, very vague. They'll say perform the indicated operation. They won't necessarily tell you which one. Sometimes they'll be nice and say find the difference or subtract. Sometimes they'll be very mean and just say simplify, which could mean a dozen different things. But it's not too bad. You'll know that it is a subtraction because there's a minus sign between the parentheses. It's going to be in front of one set of the parentheses. And what you'll do is you're going to distribute it. Distribute it meaning you're going to change the sign of each term in that set of parentheses. So let's take a look at an example to see what I mean here. You see this set of polynomials, again, they each come in a set of parentheses, which you don't strictly speaking need after this first step, but they are important for right now because this minus sign here applies just to the second set of parentheses. A minus sign always belongs to whatever it's to the left of. So that means everything in that second set of parentheses here is going to change signs. Then you can think of it as almost a negative 1 that gets distributed. That's technically what's going on. So it's going to change the signs of this term, and this term. They're all going to change. So that first term started out life as 4x to the fourth, and that 4 has nothing to the left of it, so it's understood to be positive. And when I distribute this, it's going to become a negative 4x to the fourth. All right, what about my next term in there? Well, it has a negative sign in front, and when I distribute the negative, it's going to become a positive 2x to the third. And what about my last term? It starts out life as a negative 5x, so when this distributes in, it's going to become a positive 5x to the second power, excuse me. All right, and it's just that set of terms in the second parentheses that change signs because that's what the negative sign applies to. It applies to everything in that second set. Again, don't do that if there's a plus sign between these parentheses, only if there's a minus sign. And then what I'll often do is just bring everything else down. It might seem like, oh, I don't need to do that. It's already there. I don't have to rewrite it. Do yourself a favor and actually do this. You'll find that you make a lot fewer mistakes if you just bring things down and have everything on one line. So I'm just bringing down the 6x to the fourth minus 2x to the third plus 7x. Those don't change, and now I have everything on one line, and I can pretty much just ignore everything on top of that. And this just becomes an addition problem. You notice I didn't bring down that red negative sign that was between the parentheses. I burned that up. I used that in the distributing, so it's no longer actually there. So don't bring that down on accident. All right, now that I've done that, it's just an addition problem, and I can combine like terms like we did before. So what I'd encourage you to do is pause the video right here and try to combine the like terms just like we did in the previous example. Start with the biggest exponent and work your way down, and we'll see if we get the same answer. All right, let's see what you got. When I combine these, I've got x to the fourth first, so 6x to the fourth minus 4x to the fourth. So that's 6 minus 4 is 2x to the fourth. And then I'll do my next pair of terms is the x to the thirds. So I have a negative 2x to the third and a positive 2x to the third. Well, negative 2 and positive 2 are different signs, so I subtract, and 2 minus 2 is 0. So those just cancel out. Don't bring down any x to the third powers. Next up is x to the second power. I don't have one on the left, but I do have this 5x to the second power here, so that ought to come down next. And I'll bring down with the sign to the left of it, plus 5x to the second power. And then I have a straggler. That last term is the plus 7x. And if I hadn't caught that, I'd know, well, after 2, I should check to see if there's any exponent smaller than 2, and x to the first power is just written as x. So that's plus 7x. You don't write the exponent of 1. And so that's my final answer right there. One thing that I'll mention is I'm writing these in what's called standard form or standard notation with the exponents starting with the biggest exponent and working your way down. If you don't do that, it's not wrong. Hawks will still accept that answer. It's not wrong, strictly speaking. It's just kind of tacky. It's considered good form to write your polynomials with the biggest exponent first and working your way down. So that's just generally a good idea. All right, a lot of stuff in this particular chapter, but just to summarize, you're basically going to be combining like terms. Always make sure that you start with the biggest exponent and work your way down just so that you can stay organized. Like terms have to have the same exponent, so only combine the terms with the same exponent. If two terms subtract to 0, they cancel out, so don't write the variable at all. If they subtract to 1, your coefficient will be 1, and don't write the coefficient if it's 1. For subtraction, just make sure you take that negative sign that's between the polynomials, between the parentheses, and apply it to just the parentheses that it's in front of, that it's to the left of. So the second parentheses in most of these examples. And it's just going to change the sign of every term in that parentheses before you combine your like terms. I encourage you to rewrite things over on the next line, just like I did here.